Tonight, a group of mechanical engineering students decide to do a software project. Graphic design becomes my passion. Yaz learns about colours. Michaela has a camera. And Jared connects to Wi-Fi. Our combined geniuses let us build a software that detects resistors, so geezers like you don't need to read the colours. It works sometimes.
Okay, before we get started, here's a quick lesson on single board computers. This is a Raspberry Pi. Now this, hold up, let me play the SpongeBob clip.
It's not just a folder, it's a rock.
Thank you, SpongeBob. Now the ROCK is quite a powerful piece of technology, especially the newly released ROCK 5B platform. So much so that Okdo made a competition for people to come up with insane ideas that can show the world what the ROCK can do. They call it the Okdo ROCK Engineering Challenge. Now there's a small problem. I've never used a single board computer in my life, and neither has my team. Did it work? Guys. We got Yaz. She's a mechanical student who tore her ACL and now wants to be a programmer. Michaela. She's also a mechanical engineering student who also did a Bachelor's of Creative Intelligence and Innovation just like Yaz and myself. And then we have Jared. The Mechanical and Mechatronic student who I also now work with. So including myself, that's about 1.5 mechatronic students, 2.5 mechanical students, a prize worth $50,000, and 0 single board computer experience. Yeah, that looks right.
Temporary failure in name resolution.
Yeah.
Well.
Oh yeah, and no actual idea. That was until, while working on the airbending project, it hit me. Electricity is kind of like Kanye West. It's hard to figure out what it's going to do, but you just know it's going to do something. This is why smart people make models, which allow us to simulate what's supposed to happen so we can check our real circuits and figure out our incompetent mistakes. Now, what if there was a way to take our little prototype circuits and convert them into a digital simulation? So I wrote things down in a book, convinced the team about the idea, asked electrical students and lecturers for feedback.
Yeah, I'm not seeing it.
And it was finally time to get cracking. The first thing we need to do is set the boundaries of what we plan to achieve in 12 weeks, and when you factor in our lack of experience, knowledge, and the inescapable procrastination during coffee time, we decided to reduce the scope down to working with just resistors. Not the ones that are used on PCBs, just the ones that have color bands on them. So here's the plan. In 12 weeks, we were going to build a machine in which you could input a bunch of physical resistor photos, which will first be detected using machine learning. And for each resistor detected, the color bands will be identified using computer vision, allowing us to determine the value and tolerance of each resistor. From there, we will make it possible to upload these in our dodgy electrical simulation software. And of course, this will all be seamlessly connected to the ROCK 5B single board computer. In terms of roles, Jared will take care of detecting resistors using machine learning, Yaz will work on identifying color bands using computer vision, Michaela will sort out the plan for external hardware as the mechanical lead, and I will figure out how to build a usable interface for this project and integrate everything into the back end accordingly. And so, the journey of the ROCK Electronic Circuit Digital Twin, or RECT, began. The GitHub repo was created, the ClickUp was set up, and Mark, our client and supervisor, explained what he was looking for with our project.
Hello. It's important that you make something great.
Alrighty then. To get started, we created a bunch of morphological charts to prioritize and understand our possibilities for each section. Ultimately, Python was the obvious choice to be the basis of our entire project because it's easy and has a lot of supported libraries for what we're trying to do here. This allows us to use OpenCV for computer vision and gives us a couple of options for creating the GUI. We chose PyQt5 to build our interface because our tutor told us it was good, and he almost threw up when I mentioned Tkinter. For the machine learning portion, we decided to use Yola v7 because a mate of mine told me that it seemed pretty chad by the numbers. On the mechanical side of things, it was likely going to be a matter of 3D printing a stand for the project and mounting a camera and the ROCK amongst any other items we deemed necessary. Speaking of cameras, Yaz works with someone with a PhD that has done computer vision before, and his first recommendation was to go get an OpenMV camera, and we found the last one in stock in Australia, so we bought that immediately. It was clear that the best way for us to learn was to dive straight into prototyping. We began to play around in our sections, gathering inspiration from pre-existing projects to help us make our next decisions. Jared's brilliance in Google and ChatGPT led him to finding how to run Yola v7 on the command line, and after finding a database of thousands of resistor photos,
Why?
it looked like this project may actually come together.
It's all breadboards.
Wire breadboard is what I did,
Okay.
and it needs to be breadboard resistor wire.
Yaz's experimentation and discussions with her CV sensei led her to build a plan for the color band detection. The first step was to identify the edges of each color band by making the image grayscale and binarizing it. After finding the edges, she would calculate the average color within each contour. This worked terribly, because computer vision relies on the planets aligning as well as Mercury being in retrograde. Fortunately, Michaela has a PhD in astrology, allowing her to control the mystical arts by performing experiments on the effects of lighting and how that impacts machine learning and computer vision components. To control the lighting, our mechanical prototype was a literal black box. Now, I wanted to be an animator growing up, and I was able to take my artistic genius into wireframing the GUI for both the computer vision interface and the electrical simulation. For the CV interface, I found this guy and copied his code to figure out how PyQt5 works, but this guy didn't thread his camera like a naughty boy, so I built this. And would you look at that, a responsive camera. Isn't that cool? Another thing that I forgot to mention was when this competition ends. It's on April 12th, so in reality we don't have 12 weeks, we have 6 weeks till the competition. This resulted in a lot of tension in the group.
I didn't say that. I don't even know what you're talking about.
There was no way we were going to have a working project before the competition deadline, so we did a bit of tomfoolery for the competition's video showcase, using some movie magic to make it look like we had a working product. And with the rock competition behind us, we made some decent progress. Yaz altered her CV code so that instead of drawing the contours first and then finding the colours within them, she would run through each colour and filter everything out of the image for a specific colour known as colour masking. From there, she would merge this masked image together with the original binarized image, which will help filter out all the background noise. She would then draw the contours, checking if they were appropriate size and aspect ratio, and if they were drawn on top of the original image. This worked a lot better, and once it was deemed ready, we integrated her work into the CV interface. For now, you'd input a cropped image of the resistor, and the computer vision will do its magic to find the color bands, and thus, the value and tolerance of the resistor will be found. Also, we eventually bit the bullet and decided not to use the OpenMV camera, since its poor resolution made it difficult for machine learning to identify resistors, so we did something more commercially viable instead. Phone cameras.
You know what? Her getting chicken from Sushi World is like using an iPhone camera to vlog.
Yeah, well, this is a Samsung thing.
That's
The first thing we needed to do is ensure that the photos taken from phones were actually going to work with machine learning, and it was fine. Michaela also released Mark II of the box, which now had translucent panels to diffuse any external light and reduce glare, while also making it not too dark. The drag and drop element of the electrical sim was also done, which was a relief because ChatGPT wasn't cooperating, though it did show me why my tutor skitzed it over to Kinta. We also turned on the rock for the very first time.
Ooh, what's going on? Oh. So when I said, is it gonna blow up? And you said yes, you knew that it wasn't probably actually gonna.
No, I did it for comedic effect.
Well, that's not fun.
Blows up.
It could.
But before we moved on to do slightly more intense things than turning it on, we put on a random heatsink that the lab supervisor gave us. He also gave us a Wi-Fi module. Thanks, Michael.
Incorrect, I haven't set one, it's fine.
The password and the username is rock and roll.
Oh.
All lowercase? Yeah.
Wait, how do you know that?
Because I was doing the research.
You're a legend.
Yay!
For the most part, considering we were pretty out of our depths for this project, things were moving on pretty smoothly. That is, until we attempted to port our project onto the rock. You know, in the last week of class, we tried to download our code requirements, and everything was fine. Except for PyQt5. It turns out the ROCK 5B has an ARM processor. Know what that means? Well, we didn't either. We basically have x86 processors and ARM processors. x86 architecture is your typical AMD or Intel CPUs, and it's the one in most computers. But ARM's processors are normally used in smartphones, tablets, and single-board computers like the ROCK. The problem? Well, some things are very difficult to run on ARM's processors unless they are supported for them.
And if you guys are struggling, we can help you. He can help you. I'm not going to help you. I'm trying to help people now.
Yeah.
But
Try again.
okay. Are you guys there?
Yeah. Sorry, we're like working.
Wait, so what's happening? Well, I'm going to G Stadium?
Yeah, just come down to Darling Square.
To make matters worse, we put together some numbers to see how well our parts are working, and from computer vision, it's not looking too good. Some might even say bad. And to top it all off, we still needed to integrate machine learning. computer vision, and the interface together to produce a decent prototype. Integrating machine learning into the interface was simple enough. We just convert the detection command line code into a function and call it once an image passes through. The harder part is connecting the color band code with the resistor detection. We'll come back to that later. On the mechanical side of things, the team was amazed by this thing called an Elmo. So Michaela built Box V3, which wasn't really a box anymore. It's made from core flute and can easily fold down for great portability. Yaz also fine-tuned the color detection code, so it was working a bit better. Since we plan to use smartphones for our camera, we need to make it possible to choose a specific camera connected to the device. So I made this quick message box, which I used again for connecting the machine learning and computer vision modules together. And now it was time for the impossible, getting the ROCK working. We were treading uncharted territory. First, it was the Wi-Fi module. The ROCK documentation didn't list our 8265 Wi-Fi kit as compatible, but it did list a 7265, so we tested it anyway. And after 6 hours of scrambling around, finding the drivers we needed, we finally got the Wi-Fi working. This means we can use Iterating as a third-party software to use our phone as a webcam, as the software needs both devices to be connected to the same Wi-Fi. The next step was to find a workaround to get PyQt5 working on the ROCK. This was sorta important, considering that the entire project interface was built using it. We were running Ubuntu on the ROCK, so maybe if we changed the OS, it might do something. So we tried to get PyOS running because the internet told us that PyQt5 works on it, but unfortunately we couldn't run it on the ROCK. So we got Debian instead. While we couldn't pip install the PyQt5 via our requirements, for some reason it was letting us download it if we did a sudo apt-get install. So what if we trick the system, find out where we're downloading the apt-get install, and copy and paste the files into our virtual environment?
I think we did it. That's a CV2 error, that's not PyQt5. I think we may have solved the entirety of ARM, dude.
On a momentous occasion, we've actually just installed the requirements, we've commented out PyQt5, and just copied and pasted using the sudo get. This is it.
It's a final countdown.
This is it. Oh, well. And we were stuck at this issue for a while, so we decided to enter the Council of Absolute Nerds, the Rackster Discord. And from there, we found Amazing Fate. Now, Jad began to abuse the mod with questions, and for some reason, he decided to help us by telling us if we can run the PyQt5 examples. And we could, so we did a massive audit of our code, commenting out everything we can till we figure out what's causing the error. Turns out, it was OpenCV. But when we tried to run OpenCV without PyQt5, it would work. The issue was something is conflicting between OpenCV and PyQt5 libraries. After scouring forums for hours, attempting every possible solution available, we finally found something. There was 2 XDG plugins in PyQt5 and OpenCV libraries respectively. So, I deleted one of them into the virtual environment and just deleted a random thing that the error was telling me. So I just deleted it, so let's see what happens. All the code is the exact same as what it is on the thinger. Okay, that's awesome. Oh my god.
Okay, it's rolling.
Okay, as you can see here, we have a little box, and in the box we got the thing. And then if we run our Epic system, we take a photo and we just press yeah. And now it's doing a bit of movie magic. We'll just do a bit of waiting. If we get one round, then we get everything right.
Yeah.
Did that work?
Oh yeah.
It detects all 4?
Yeah.
No.
Can you try another one?
No, because nothing's working. We had achieved the unthinkable and ported our project to the ROCK. There were still improvements needed to be made and a client delivery to be fulfilled, but the grounded team managed to develop a resistor scanner using AI and computer vision. We didn't win the competition. We may not have showed the world what the ROCK can do, but we definitely showed the world what 4 decent students who started with nothing can do.